Hello, calculus fans! So we can define a function of any number of variables. We've already seen functions of one variable, that's what we're used to. We've been talking about functions of two variables, and even three variables, but we can do this with any number of independent variables. We can talk about a function of n variables. This is a rule that assigns to an n tuple, x1, x2, x3 up to xn, of real numbers, we get an output that is a unique real number, f of x1, x2, x3 up to xn. Let's suppose that we have an assembly line that has n steps. X sub j represents the amount of time that it takes to complete step j. Then we could say that f of x1, x2, x3 up to xn is going to be the amount of time that it takes to complete one item on the assembly line. Now, it may not be that we just add up the individual times. If you have an assembly line, a lot of times you can do things in parallel. A function, f of x1, x2, all the way up to xn, is a real valued function whose domain is a subset of Rn. A lot of times we'll use vector notation to write functions a little more compactly. If we have a vector, x, which is x1 through xn. This is an n vector. Sometimes we'll just write f of x, where x is a vector, instead of writing f and then writing the argument out with all n terms. And because we have a very nice one-to-one correspondence between points and vectors, we have different ways of looking at a function defined on Rn. There's a function of n real variables. There's a function of a single point variable. Or there's a function of a single vector. And all three of these will be used from time to time in different ways. Okay, that's all for now.